For you that don't know me, I am Andy Bosch with Kimley Horn Associates. I've been doing this for about 20 some years. I'm not going to probably keep track of the years after about 20. I'll just say 20 plus. I've been doing a little bit of everything from development to major transportation projects. Currently doing a lot of county and city projects and some bigger transit projects. So yeah, a little bit about me, a little bit about this class. I think if you attended last one, you can know that my thought bubble was a little bit about the Oregon Trail about this, but really what I'm trying to portray is like the idea of understanding that whole path that you have to take to get from the point A to point B, and how kind of complicated corridors can end up being, trying to take some 2D line work and giving it life and making it 3D and getting all the data that you can out of that corridor so that you can get good earthwork numbers and let the computer or the program do a lot of the work for you rather than you having to do a lot of hand calculations. So that's kind of the overall goal of this class. The agenda for this week is going to be looking at intercepting slope grading. When you have those two corridors that cross and you got to figure out how can we tie those two surfaces together to not only make good looking cross sections, but getting your surface to look right as well at the end. We'll dive into a few pointers to think about when you're creating your surface from a given corridor. Then we're going to look at the creation of strip surfaces and how you can take your existing surface, hold that down, and utilize that in your average end area earthwork calculations, and the different options that you have on that to pull out quantities from average end area, as well as using the tin subtraction calculations just to verify some numbers and working both directions just to verify that your numbers are right, so you're not just leaning on one set of numbers and thinking that's accurate. Always good to double check. And then hopefully some time at the end for a little Q&A. Again, I'll just tell everyone that if you can go ahead and put your questions into the Q&A bar, and I'll try to answer those as well as I can. So with that, I'm going to get out of PowerPoint because no one likes to be in PowerPoint the whole time, and we'll cycle over to AutoCAD. So hold on here. Why is that giving me? All right, something's erroring out. Give me 1 second here. All right, got an error, but all's good still. Thank God. All right, so the first scenario that we're going to be dealing with is this intersecting slopes. And just to try to give you an idea what we're kind of looking at here for this grading scenario is I've got this magenta line right here cutting right down this driveway, and you can see the correlating section down here. This is my sample line right here. I'll highlight it. And this is the correlating section down here, and everything's looking pretty good. We've got quite a bit of cut happening here. We've got a driveway partway through. We've got a trail running through it, and then we're just trying to tie back in at a decent grade. So everything is looking right here, but as you can see, as we move out, I've got another section cut here. What we have is when our daylight slopes go out from this cut section, we're kind of coming up, and really what we want to do is probably right about this point here, switch over and start sampling the surface for the given roadway instead of the actual existing ground surface. And my CAD just froze up a little bit there, but so what we'd really probably have is a nice line kind of running from this point here to a point right here where I'm tying into our trail. And really this is our intersecting point there. So and as well as figuring out our ditch grades, we'd want to have that target that proposed surface off of the roadway. So I'm going to switch drawings here. The normal way to do this is, if you think about this, what we could do is we can always go in here. I'm going to edit my targets. I'm going to pick on this one here. So this is the same corridor setup and everything. I'm just using this as kind of showing how this could work. So if we look at here, instead of targeting the existing surface, I could target my westbound. I can hit OK, that'll rebuild, but it's not building out right. And the reason why it's not building out right is that surface isn't creating, my proposed surface isn't building underneath that given, underneath the given roadway. It stops short because in my cross sections, I can't have that ditch going all the way through. It's going to look weird. So if my surface doesn't build all the way underneath that, it's not going to be able, my subassembly that's right here looks vertically at that point and says, is there a surface there? Am I in cut and fill? And what do I do? So that's issue number one, is that our surface isn't continuous through this area. The other option that we have, and I've already targeted this one to the surface. So this is fine, but then our surface, our corridor here goes out past. And really what we want to do is have it target this line right here. And what I have here, what I can do is I go my home tab, and I'm going to go over this a little bit more, and then when I go back to the other one, but I'm going to go create feature line, create feature line from corridor. I'm going to grab this daylight. Oops, I got to do it twice. We're just going to extract that one real quick. I'm just going to do the daylight. I'm going to extract that. Now I could use this as a target. And what I could do is split this region, split up. So let me go in and edit my targets. And I could say what I've got is a ditch target off slope for matching my outside elevation for my driveway slope. So I could say grab this one. Oops. Let me grab this feature line. If I grab it here, I'll just use the name of the default. And then if I grab the driveway slope outside elevation for that feature line as well, I hit OK, I can hit OK. And now we're getting some weird rebuilding happening on this. So if I rebuild this corridor, it looks fine. Now you can kind of see some stuff is starting to adjust and not build out completely right. And what's happening is we're starting to get into a weird loop where nothing's going to be built out completely, because we're making a kind of a looped or kind of a loop happening with this, so nothing is completely built out, and we're never going to be able to really get this to look the way that we want to. So how do we solve this scenario? And the best way that I found, and not that this is easy, is but what I like to call is an auxiliary corridor. What I have is another corridor running down this side that is doing basically everything that I have my mainline corridor doing, but I'm not omitting these areas where I'm going underneath the given driveway. It's building out completely through that. And my assembly that for this one is looking something like this. This is my regular roadway profile with my ditch and my trail out here, and then I'm daylighting. And if you attended the last class, you know that this is my custom subassembly that I'm using for my daylight. But you'll notice one other thing that I'm doing is I'm pushing that out another 100 feet or so. And I'm doing that just so I make sure that my surface creates all the way out where it might have to cross over. So if you look at here, at this point here that my surface has to target, if I didn't have that surface where I built this corridor here, if it's not perpendicular to this point, if there's not a surface underneath here, since it kind of it pulls back in due to the grading of the slope, it's not going to be able to find this point. So I have to make kind of a dummy surface that runs all the way out to here. So all I do is just add a generic link that goes out a given distance. One thing I'll note that if you're not using this one of my custom subassembly, you can't really use this daylight generic one and attach on these edge, because this is just the display purposes. So I recommend, if you're going to do this, to utilize the generic, let's see, what is this one, slope to surface. And then you can attach another generic assembly off that and go out. So really you can move this portion down here and replace that, and you're going to get the same scenario happening. So let's look at how this process really works. I'm going to go back to my cross sections here so you can kind of see things as they update. So again, I'm going to go back into here and I'm going to edit my targets. I'm going to go in here and edit this target. Instead of this existing ground, now I've got this auxiliary westbound. I'm going to hit OK. And now you can see that I'm going to get some good, oops, let me rebuild that one more time. When you edit the targets, it doesn't rebuild fully out. And now you can see that that cleans up that section there. You can see that it's no longer, my cross sections are looking right. And now I'm going to get good definition to tell where my bottom of my culvert should be placed at due to the grades coming off my driveway. So again, let's look at this scenario here. Again, we got a big cut section in here. We got to try to get this proposed slope of the driveway to kind of follow that proposed slope of what the main line is doing. So first thing I'm going to do is I'm going to split this region, and I'm just going to pick here, and I'm going to do an apparent intersection. And just to verify, I do have two corridors. There's my mainline corridor, and then I have another corridor style. And thinking about our code set styles, all I have turned on is the daylight for that one. And that helps me say that, okay, everything's lining up here. There's nothing I have to do for this second corridor to make sure it lines up with the first. So I split these two regions, or I split this region here. I'm going to edit the targeting. And I'm going to go again and do the auxiliary westbound. Hit OK, and rebuild. And now you're seeing things are starting to line up a little better here. We still have this corridor is coming out and daylighting up, so we're going to have to fix that. But this corridor now is following that slope of the proposed grade. So before I do anything, and I touched on this a little bit, just note that on any corridor, you can extract a defined feature line from the corridor. And again, those feature lines are any given point that is coded similarly along your corridor, and it runs parallel with your corridor. And you can extract these as linked feature lines, meaning that anytime that your corridor maybe adjusts or moves, this feature line is going to update along with it. So if I grab this feature line, and it's going to grab anything vertically to that. I just want this one feature line. So if you had two codes similarly coded at the daylight point, because if you had depth, if you had top of daylight and bottom of daylight, it would grab both of them. But really, we really just want to make sure that we grab that top, and we can hit extract. When I do that and I grab this AutoCAD feature line, you can see that I can't really do anything to edit this elevation. Even if I go in the elevation editor and I bring this up, everything's just grayed out. I can't change anything there. So that's dynamic, and that's a good link that we want. I've already got this split out to where my corridor wants to line up with that, my driveway corridor, or my main line. And just to show you what's happening here, what I can do is I'll swap these out. Instead of daylight, I'm just using the generic shape trapezoidal. And I'm using this one because I can point it to a given offset and elevation at this point. So I can use that feature line as that given point. So I'm going to go into my corridor and go corridor properties. And I normally would do this with custom or conditional subassemblies, but for this, I'm just trying to keep it a little simple. And we're just going to do it in this manner instead of just making some different regions. And I can't remember what I named this exactly, so I'm just going to select this one just to be sure. Okay, driveway daylight. Now I can go in and edit that target. And again, what I'm looking is for that shape trapezoidal, and this is another big thing. Make sure that you name your assemblies something that you can find them easily when you're going in and doing your targeting. I got the switch to feature lines. I'm going to select objects, and I can go in and select that feature line right there. I can just name that the default. So now that is populated in as my offset. And I'm going to do the same thing for my elevation for that driveway. I'm going to select from drawing. I'm going to select that feature line. And now that's going to give me my elevation. I'm going to hit OK. I'm going to rebuild the corridor. And now you can see that that corridor sucked up. This is still my auxiliary corridor building out here. It still has to build out that far because I need that, so I make sure that everything is building out properly. But if I go back and look at my cross sections now, you can see that I'm getting that good angle point happening where my two intersecting slopes are crossing over each other. And just to show you that surface again, so I'm going to go over my corridor surfaces for this. I'm going to turn this one on real quick just to show you what that looks like. I'll just mark the corridor out of date. So you can just see all I'm trying to do is just make sure that from this point here, there's a surface underneath this point, so I make sure that it can read that auxiliary surface. If I didn't push that out that far, the surface would end back here and it wouldn't be able to read that given point because there's not that proposed surface underneath there to tell it vertically from this given point. If the surface doesn't exist underneath this given point right here, it can't tell this subassembly what to do. So I'll advance ahead and show you what this looks like at the end. When we get all said and done, this is what your surface will look like. And you're getting that nice angle point with where your intersecting surfaces are coming together. And you're also getting that good ditch definition to tell you where to place your culverts and getting that good elevation. So you know that you can double check that you've got enough depth underneath any of these driveways. So a little complicated. I know it's not easy to maintain two corridors, but I haven't found really a better way to do this scenario yet, but this comes in handy for many different situations. To move on from this, the next thing that I want to show is give some tips on surface creation. So in your corridor properties, there are surfaces, and we have the ability to add any bit of amount of data in here. And this is just my FG surface. And what I normally do is add for my finished ground surface, I'll add all my top links. Again, the links are those lines that are perpendicular from your center line. And I will also make sure to set them to say all top links for overhang correction. What that means is, say you had a custom subassembly and maybe you didn't, or you forgot to turn the bottom link not to say top. What can happen is that your surface gets confused as to what link it wants to utilize, that top or that bottom link. By utilizing this, it'll correct and just use all the top given links. So again, that's where it kind of goes back to what I was speaking about last couple of weeks, is that it's really important that you understand your code set styles, and if you're making custom code sets or you're adding codes to any given assembly that has the ability to add codes in it, that you know what you're adding it for, because it's going to help you define that surface. Another thing that I will do for more definition is to add feature lines, especially for my curb lines around corners. You've maybe seen this, is sometimes if you don't add in these as break lines, your surface will tin oddly through those through radiuses. If you add this in, it just adds another break line definition to it. So again, these feature lines are those parallel lines that get created with your corridor as you're building it out. And you can add any one of those definitions into this given surface. So if we want to do this for our datum surface, again, I usually like to name my stuff this way. I'll say datum at the front. I'll put this in here. I'll switch this over to links. I'll find that datum code here and I'll add it in. I'll make sure that I add those as bottom links, and this is the other one. I don't think I hit on this, but I also like to add these in as break lines. A lot of times this will give you better definition on that surface. So always try to set your overhang correction and always select add as break lines. And then if I wanted to add any more definition to my datum surface, I could add in, let's see, we have a datum code here that I could add in, and that's going to give me another break line to help define my datum surface better. And I get it, okay, and I'll just mark this corridor out of date. We don't need to see that. So that's kind of going through. Oh, one other thing I should probably touch on too while I'm in there. I'm going to go back in the corridor properties. I forgot to touch on boundaries. Also note that you can add in the corridor extents as outer boundary to give you that kind of shrink wrap boundary on your corridor so that your tin lines don't go across your daylight lines in some areas. And I think you can see that on my, let me just go ahead and rebuild this quick. We'll see how long this takes. And I think you'll see that some of the stuff will clean up out here. So another important thing to remember, always add in that definition so that your boundary, and you can see that that cleaned up those areas there. Sometimes those do get tricky in that as you build a corridor out for a while, they might not stick with it, knowing that that's the boundary. Note that there is this create boundary from corridor options underneath the home tab, and you can go create boundary from corridor. And if you grab that, it'll just grab the outer limits of the corridor as the boundary. And then I just offset that maybe like 1/10 and then add that back in as a given boundary. I've also seen that help when you're trying to paste surfaces together. There's weird things that happen there as well. And I won't get too far into that, but just another thing to think about. So we've got our surfaces, we've got them all compiled, pasted into one overall datum surface. Again, the datum surface is the important one that I'm really looking for so that I can get my good earthwork numbers. So the next thing to think about is how do we start utilizing our existing ground surface and start to manipulate that to hold that down to represent that area of good material. And what I mean by that is, you know, when we start thinking about our existing roadway, we've got existing pavement, we got existing topsoil, we maybe have some sidewalk areas. All those get paid probably as separate line items on your contract, and you don't want to quantify those. We want to remove those given items out so that you know what's below that as good material. So one method that I like to use for this, you could go down the method of pasting different surfaces together. And if your scenario is simple enough that everything's just a given hold down across the whole site, like say you ask your engineers like, well, how much are we material removing across this whole site? And if he says, just assume a 1/2 foot across everything, makes your life pretty easy. You can just take your construction limits, you know, make a new surface, paste your existing ground surface in there, drop it a 1/2 foot, use those construction limits as your limits for, or your boundary for that given surface, and now you've got a hold down surface. But if it gets more complicated in that you have different hold downs for different areas, so say maybe we got 8 inches of bituminous and whatnot to take out of the roadway, and we've got maybe a 1/2 foot of topsoil to take out in green spaces, and maybe it's only 4 inches of sidewalk. That gets to be a little bit more complicated. You could try to take all these different areas and paste surfaces together and put boundaries on them, then paste them all together. And that gets to be real painful real quick. So I wish I was smart enough to come up with this scenario, but a gentleman of Craig Dysinger came up with this idea of differential tin surfaces. And he gave a class at AU in 2019 called the Handyman's Guide to Differential Tin Surfaces. And he's been doing this class for quite a few AUs. But this is a really slick way to do that surface, get all those surfaces created, maybe a little bit smoother process where you're not pasting all these surfaces together. But it's really leveraging tin subtraction to get you there. So let me see if I can explain this in a manner. So what I have is different areas representing my different hold downs, whether it's my topsoil hold down, I've got my green space, and I've got my pavement areas, my bit, and then I also have everything kind of offset like 1/10. I've got a border, a boundary around that I just offset 1/10. Because when I create my surface eventually, I can't have these butt up right next to each other. AutoCAD doesn't like vertical lines when it comes to surfaces. It likes a slight bit of offset to everything. So as you go around and you create all these, you've got all these different areas. And once I get these all created, and these are just polylines, there's nothing more than polylines, I will go into my modify and design, and I'll just do edit polyline elevation. And right now this is set to 1 foot for this polyline, and that's good enough for me. That's what I want. So I'll just select this polyline, and that's 1 foot. That's the elevation that I want. And that's what my given hold down is going to be for my green space. I want to take out 1 foot of topsoil in all the green spaces. So it's a little bit backward from what you normally would think, is that you'd want to drop it -1 foot, but we want to go to +1 foot. So I will do that for all my green spaces, just the actual limits of my areas, not to the actual boundary lines. And I'll do that for all the other given areas that I'm trying to hold down. Then what I'll do is I'll take all these green spaces and I'll just isolate these. I can go ahead, since I got them all layer controlled. I can go in and then I can add all this information into a given surface. And I like to use different folders to break up my information, but here's my base surfaces. So I got my green space, and I'm going to show you what's internal to this surface. My definition is this: I've got a bunch of break lines added, and that's just adding in any of these polylines that on my surface that I've added in. So I will just go in here and say, go to my green space definition, break lines, I'll just do add, and then I'll make sure that I have some good supplementing factors in here. And then I can just go ahead and hit OK, and then I'll just add all these lines in there. So that's giving my definition, but I don't want them tinning all the way across, because if I just add these in, it would tin across this roadway, and I don't want that. So then what I'll add in as the next definition to this is I'm going to add in a boundary that's just called hide. I want to hide all this information. So I've got this overall one here, and that's going to hide all this data. Then I go back through and then I isolate my outer boundary. And this is my boundaries that are off by just 1/10. And then I'll add that in as my show boundaries. Again, if we go in and I go to boundaries, add, and we'll say show, I'm going to just grab all these, and that will then allow all those just individual areas to show up as my given surface. So what we just did there was create a surface that's just at that green space, but a +1 foot across this whole area. So once we get done doing that for our pavement removal, our driveways, whatever has a different elevation to it, then what we can do is the next step is a comparison surface. And what I'm doing is, if I look at my green space here, and I'll just look at the properties of it, I'm using my base surface as green space. And then I'm doing my comparison surface as EG. So it's a little different too of what you're thinking. So if I go to and I'm going to go into this a little bit more, if I go to my analyze, my volume dashboard, and say I create a new surface, really my base surface is any of my comparison surfaces, my green space, and then my comparison surface would be the EG. And what this is going to do eventually is just end up holding down this EG, the given amount of the green space. And I know that's kind of weird thinking, but it does work really slick for this. It's just going to take that surface in this whole area and say any points that land inside there, I'm comparing that to a +1 foot, and it's going to hold that whole area down 1 foot. Once I get that compiled together, I've got all these different ones. I can then take these given surfaces and paste them together in the surfaces that I want to data shortcut out and use for my analysis of my earthwork. So one that I always do is just a topsoil strip. I keep that one separate because I want to compare that from my existing ground to my topsoil, so I can get an average area, so I can get a tin subtraction and an average end area out of that area. And then I'll compile all the other surfaces as well into one. So I've got my roadway, driveway, walk, green space, and then for this one I had some extra subcut areas that I had to take into account. So when I get done, what I have is all these different surfaces, and I'll turn this on real quick just to have it show up. Now I've got this hold down surface that I can utilize for my whole project. So again, this is kind of a complicated process. It took a little while for me to get my head wrapped around it, but it works really well. It is way better than pasting a bunch of different surfaces together. The big thing just to think about is define your given areas, make polylines out of them, make boundaries, offset those polylines, and then give all those polyline areas a given elevation, and then start pasting those polylines into a surface, hide them, and then show them again so you get these individual areas. And then it's just a tin comparison from there. And you'll get yourself a really good hold down surface to utilize for your earthwork analysis. So we've got our proposed surface, we got some strip surfaces. How can we utilize these in a couple different manners to make sure that we get some good earthwork numbers? I've got my cross sections here, and I like to use data shortcutted corridors and create my cross sections. So if you already create all your sheets, if you've got those all cut, and usually this, you know, when you're starting to do earthwork analysis, you should probably have all your cross sections cut. You should have a good design set down. What I'll do is just do a save as of my cross sections. Since it's all data shortcutted in there, I can do a save as. Now I've got sheets that I can print out. Once I get to the end of this, you'll see that I'll have this all displayed in a manner that I can actually print out. So getting all these cross sections in here and then just doing the analysis in here also gives you a tool to have some QC on your project to say like, okay, we can go back and review, like, was this earthwork at 60%? How would that compare to 90%? Why did some areas change? So it's a good process to get into. So how do we get there? Let me, I'm gonna move this thing. I don't know why this is not. All right, I'm just gonna do it this way. I don't know why I can't get that too. I'm gonna go to my compute materials. I don't know why I can't get this to hide. I'm gonna go compute materials, and I'm gonna pick my sample line group, and I'll select this one here. And now this is where I can select my design criteria. I'll show you how to create one of these in a second here. So I'm just gonna pick cut since I'm in my cut scenario. And you can set this up to be all these standard surfaces here. If I keep my surfaces standard, I can just click on here and map same objects, but I got, of course, one that I didn't name quite right, but I can map that real quick. So all this is gonna do is, I already set up a criteria before, this is just gonna populate everything for me. I can hit okay, and it'll go through, it'll do the calculations, and it'll add that all in here. I can expand this again. So now you can see that as I go through here, I'm getting my earthwork analysis to happen. It's using my hold down surfaces. It's figuring out my topsoil stripping areas here. I had a lot of topsoil removal on here. And then I'm getting into my, my actual earthwork numbers on some of these here. This is like good material that I can still use on the project. So we've got all this hatching happening. This is good. I can print this out. This is showing in color. One other thing that we can do, a couple other things we can do is before we print them out, it'd be nice to have some tables on here so you can see the amount of cut and fill for each section. So if we go to section view group properties, we can go to section views and we can go to volume table. So we're just going to do material, basic. I'm just going to add it. So these are the two things that I calculated out. Actually, I'm going to step back for a second here. I'm going to show you what happened there with the, I'm going to do compute materials, and I'm going to go back to this one. And you can see that after I did that the first time, it now has these two materials that I defined. My common excavation, my topsoil strip. And I defined this previously as datum above for my common excavation above my datum but below my EG strip, and my topsoil is below EG but above the topsoil strip. And I can set different shape styles for how that's going to display in here. And this is another important fact. Understand what these quantity tabulations do for you as well, the quantity types. This is especially important when it comes into the tables. These will help define what your table, if you do cut and refill or earthworks, like it starts to affect how the tables display and how it actually calculates that information. So I'll hit on that in a second here as well. So I'm just going to go back in. I'm going to go section view group properties, add volume table. I'm just going to add this one in, and I'm going to say top left, so it's all internal, and I'll go ahead and hit OK. And it's going to go through, and once I hit OK again, it's going to go through and add a volume table for each one of the sections for the given amount of area and volume for that given cumulative volume for that area or for that given section as well. So we can work through all that, and then you can print these out at the end. And again, you've got like a nice display of what's happening for that given portion or that given moment in time of your corridor or of your project. So again, if you wanted to give a actual quantity on here, if you look at material here, I clicked on that one, I can switch to the eastbound, and now you can see I've got those individual materials here. So I got common excavation. I can add these as dynamic tables, and it gives me the same information as what was in my cross sections. Just note that if you do a total volume table, that it is going to take, and I'll just add this one in, it's going to add up anything that's cut. So it's not splitting out the two things. You can see how my stationing is, it's different here. It's just, if I'd have my topsoil strip, basically it's taking those two items and doing a total volume on that. And I think sometimes people get confused by that. And I've actually had people within my own company go down this route and not understand that what we really wanted was just that one individual item, the common excavation, rather than a total volume. So understand what the difference of those two are. So that's for cut. Let's go to the fill area here and give this just a second to, and hopefully I don't crash. Yeah. All right. So we did cut, and I like to split them up between cut and fill because it's hard to see what's happening between the two. Cut can be in one section, you can do a save as and do the fill. So if we do the fill again, I don't know why I can't move this screen. So if you go compute materials, we're going to do the same eastbound again. And then this time instead of, oh, I lost my, actually, I'm going to show you how to create one real quick since I don't have it in here. If I go to my settings, and if I go to my quantity takeoff, I can do a new quantity takeoff criteria. And I can add, so this is just kind of a blank one. It's allowing you to create new materials. So I can just say fill. And I can say the surface, I want my datum. And I can add that in. And then I want another surface is my EG strip. And I can add that in. Now I can say that for my fill, it wants to be above, but below my EG strip. And then again, if you want to change your factor, your fill, you want to change the type to fill, you could add a fill factor. We also want to add a shape into this so that we have a good display there. So I'm just going to say, we'll say common, let's do, what's a good one here? We'll do embankment and we'll hit OK. So now I have a criteria. I forgot to name that. I'm going to do that real quick. I'm going to edit this and I'm going to call this my fill criteria. So again, when I calculate out compute my materials and I go to this one here and I switch, it's just asking me for these two. So if you had a bunch of different criteria, you could stack them up in the style and then it'll map it for you right away. I'm going to have to map these because I didn't name them right exactly, but it'll get you there. And notice that I didn't do corridor shapes on this. Since the way I set up my corridors is probably multiple corridors, and the way that AutoCAD works, it doesn't grab all those corridor shapes at one time when you add them in. I'll show you here in a bit, but if you do add them into your template for how you compute your materials, you can't add any to it after it computes, which is really frustrating, but you can always just do it after you compute just the surfaces. And I'm going to go to, why did that not? Below. I'm not sure why that's not showing up. The fun of doing live demos. Let me just see what happens here when I add. I'm going to go in and add some areas into this too. I'm not sure if I've got, I think that's why. I think I've got an issue with my datum surface not coming through. Let me add in, I'm going to do compute materials one more time, and I'm going to do this one. And now I'm going to add new materials. Actually, I have my fill. I'm going to add a new material, and we're going to call this sod, or let's call it topsoil. And this is where we can change the type of material that we want to put in here. We can go to structures. And this is where you can start pulling out those given areas of the shapes to use as your quantities. We can switch this to corridor shapes, and now you can start seeing that when I switch this from surfaces to shapes, I can start adding these in. If I still have this on surface and I try to add, it shouldn't do that. I have to add this. If I do this as fill, it gives me that error. I can't add that shape unless it's to a structure. Then I can start adding that in. So we're going to go topsoil, and I'm going to, again, just step through, add some of these ones in here. And this is where you can see having common names really helps you have better consistency, so you don't have to grab multiple, because I've got some as topsoil and I got some as sod. If I was better, all I'd have is one code in here. I can add that and then I would be done. So let's go ahead and we'll do topsoil placement on this one. We'll do sod, hit OK. I'll hit OK. And you can start seeing how those all start populating in here as shapes. And I can pull those quantities out again too. I can do the same thing. I can go to my section view group properties and change my volume table. I'm going to add one in. You got my fill and I got my topsoil. We can do this to the top left. I can hit OK, hit OK. And I'm not sure why my datum surface, I think I've got something jacked up with my datum surfaces that it's not figuring that out. But I should have a hatching in here that would represent all my fill as well. But at least showing it that we've got the place or the cumulative volume that we can get out of those corridor shapes as we go through our whole corridor to add those as given quantities. So again, dividing these out, you can easily print these out if you already had them cut in sheets and if you're doing a save as, and this can be tucked away into your project and just as giving something that you can look back on just to, oh, there's my fill shows up all of a sudden. I've got something jacked up with my datum surface on this one. So here's where you can start seeing those surfaces, and now they're starting to display in there. So that is the fill scenario. So you could go down and just do average end area, but I have found a couple instances in my history where if I don't do another comparison to this, I'm not maybe having the best feeling that I have my my earthwork numbers correct. So I will at least go back in and do an average end area or a tin subtraction on the two surfaces, my EG strip to my datum, as well as my topsoil strip to my EG, just so I can compare those numbers to my average end area. So I'm going to click on volumes dashboard. Again, this is pretty simple. We kind of showed this last, my base surface for one. I'll just do my datum and strip is, oops, I should do my strip is going to be my base surface, and my comparison surface is going to be my datum. I'll hit OK. And this should build out in a second here. And then you could notice, as I had before I hit on this, I had some different areas. And if you need to divide those out, don't take too long here. It's now calculated that out. And I've got, so this is the calculation of it, but then I've got these defined areas. What I can do is, if I'm calculating this small street with my cross sections that are cut for that, I don't want my overall if I'm going to compare these two from my tin subtraction to my average end area. So what I can do is just add a bounded volume to this, and forget which one this is. I can add that bounding object, and it'll just calculate out for that given area. And that's pretty nice to be able to compare all these given areas to my overall surface. Again, we can also go in here. You can place a volume report that you can create. And I think there's also a way to add, you can add text to the screen, but this is not dynamic. This stays static. One other thing on the average end area, when you get into this, you can also kick out volume reports. And if we select, oops, I think I went too far. Let me go to my cut. If I go to my volume reports, I'm going to do my eastbound, and I'm going to select this. We got a sheet style. We can do our select material. We've got earthwork, which compares the two, but I like to do the select material. And that's just a default. This comes with AutoCAD, that given file. Boy. And now it's not displaying. Hold on one second. Well, these default styles will pick up, and then you can export out a HTML file that you can actually copy and bring into Excel. So having a little presentation gremlins this time around, but that was, I'm basically at the end anyways, so I'm going to switch over to my PowerPoint presentation and do the last couple things, just to clean up a couple thoughts on setup. Think about, again, I hit on this last time, but think about those good typical sections before you even get started. Think about this as well if you can. It's always tough to think about what a good spot is to split up a whole entire project. Sometimes we might think it's this easy, but you have to kind of, as you do corridors more, you can start to think of like, would it be better to split up these given areas to allow the file itself not to get so big, but also thinking about like, how do I keep things contained so I'm not editing things in 5 different spots. So, there's no good rule of thumb there. It's kind of like what you feel makes the most sense. Before you get into the earthwork definitely think about your earthwork expectations, what needs to be the outcome at the end before you get too far along defining all this information, because it does take a while to get there. But again, you're going to get good numbers out of this. And then what is the contract required to produce? You know, when you're going through all this information, is that datum surface going to be part of your submittal? I think we're seeing this more and more now, is that contractors and given agencies want to have some of these surfaces to work off of, to either do machine grading or to do staking from. So it's important to know how much effort that you need to put in to make a good surface out of these. So just to recap, we went through auxiliary surfaces for intercepting slopes of proposed slopes and how to get those to line up to be better, to make better surfaces and better cross sections. We looked at surface creation, whether that was finished ground surface from the corridor itself or doing strip surfaces using the differential tin surface option. I know it's a complicated process, but it definitely is worth the effort to put in to get there. Average end area calculations and display. I know I had a little issues today doing that. Usually that goes smoother, but that's a good way to calculate, get calculations out of your surfaces as well as those corridor shapes, and then actually put that information on your cross sections and print that out for a documentation on your project as well. We went through some tin subtraction calculations, again, doing those two to compare against each other to make sure that your numbers are all making sense, that you have your sample lines going out far enough and that you're accounting for all the different scenarios that might be happening on your given project. And then just a couple of quick thoughts on setup and things to look for as you're moving through. So with that, if you have any questions, go ahead and post them. Hopefully this was a helpful presentation and gave you something to work with as you're going forward. And I think that, you know, these processes have worked out really well for me as I've gone through working with corridors and thinking about how to get that good robust corridor so we can get all those quantities taken out of that. And I must have done a really good job because I don't have any questions. And I wrapped up with about 5 minutes to spare, so. If there's nothing else, I will probably just leave it at that. I like to thank you all for attending this, this presentation. Hopefully you walked away with some good information.